In this problem, we're given a parametric equation, and we want to sketch it and find the rectangular coordinate equation. So first, for my sketch, I'm going to make a table. Both of my parametric equations are in terms of theta. So theta is going to be the independent variable that I plug in. X is equal to 2 plus 5 cosine theta. Y equals to 1 plus 2 sine theta. And then after we find x and y, then we'll have some coordinates to plot. So when we're graphing parametric equations, we want to pick the easiest values to plug in for our independent variable. Well, if I'm plugging in angles into sine and cosine, the easiest ones to plug in are my quadrant angles. So let's see. 2 plus 5 times cosine 0. Well, cosine of 0 is 1. So this is going to be 7. 1 plus 2 times sine of 0. Well, sine of 0 is 0. So this is 1. So the first point I'm going to plot is 7, 1. So now if I plug in 90, cosine of 90 is 0. So I have 2 plus 0, which is 2. Sine of 90 is 1. So I have 1 plus 2, which is 3. So that point I'm going to plot is 2, 3. For 180, cosine of 180 is negative 1. 5 times negative 1 is negative 5. 2 plus negative 5 is negative 3. And then sine of 180 is 0. 1 plus 0 is 1. So negative 3, 0. Oh, I'm sorry, negative 3, 1. 270. Cosine of 270 is 0. 2 plus 0 is 2. Sine of 270 is negative 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. And lastly, 360 is the same as 0. So we'll end up at our same spot. So now that I have these 5 points to plot, I will draw my axis. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So my first point is 7, 1, 2, 3, negative 3, 1. And then I'll come around to 2, negative 1, and then back around. So it goes in this circular motion, and we create an ellipse with that, parametric equation. So in the next video, we'll write the rectangular coordinates for this equation.